Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. Last week we had a moon week. We used the moon, the opportunity of the moon washing out stuff in the sky, to take a look at some stars in Cygnus that we maybe didn't always look at, and to think our way through Cygnus there a little bit. It's still a moon week. It's going to start the week on the 3rd. We're talking about the week of July 3rd this time around, and it's going to start pretty full on the 3rd and be waning away as the moon moves westerly against the background stars and wanes away as the week goes on. We'll start there. On the evening of the 6th into the 7th, so this region rises about midnight. So Saturn rises about midnight as the 6th turns into the 7th, and the moon rises right with Saturn. So about 3.5 degrees separates them. So a nice close pairing of the moon and Saturn. The moon will be about 80% full on that night still. So that's something to watch as the week moves on. But let's turn our attention back, looking west as the sun sets. As we look west, we've been sort of transfixed. We've been sort of focusing pretty hard on Venus and Mars there together in the western sky. And we're about done with that. Last week we said Venus and Mars were at about a standstill. Venus has been closing on Mars, closing on Mars, closing on Mars, and we reached a standstill last week, and they're going to start to separate. On the evening of the 3rd, Mars and Venus are separated by about 3.5 degrees, about the same distance that separates the moon and Saturn on the 6th and the 7th. And so by the end of the week, the 9th, Mars and Venus are separated by about 4.5 degrees. So if you're paying close attention, you will see that separation has gotten about, a third bigger. And so you'll see that separation growing. Now you might think, we've talked a lot about the planets being in prograde motion this whole spring into summer. Saturn, a little bit ago, turned around into retrograde motion, meaning it stopped. When they're in prograde motion, the planets are moving easterly relative to the background stars, just like the moon is. When they're in retrograde motion, we're catching up and passing them, and the planets start to move westerly again. You might think that means Venus has started its retrograde motion, and it hasn't quite yet. It will, but it is just slowing down to begin the process. So Mars is pulling away. They're both still in prograde motion, but Mars is pulling away because it isn't slowing down quite as much yet as Venus is. And you can see that on the evening of the 3rd. So let's map the stars of Leo here. You got the triangle tail of Leo with Dana Bola out there in the tail, a nice bright star. The brightest star in the region is Regulus at the base of the backward question mark, the sickle, that marks the head of Leo. Right at the curve, where the curve starts in the sickle, in the question mark, is Eta. You have Algebra as the bright star up there. It is about 3.5 magnitude. 3.5 magnitude star, very easy to see. Very easy for you to see that 3.5 magnitude star. Not as bright as Regulus by any stretch, but you should be able to see, if you have decent skies at all, you should be able to see down to 4th or 5th magnitude easily enough. Drop straight down in this orientation, go to Omicron Leonis, and Omicron Leonis is also a 3.5 magnitude star, so also nicely visible. And you'll notice on the 3rd, Mars is just west of the line that connects Omicron and Eta. By the time we get to the 9th, Mars will be right here on top of Regulus. Don't miss it, okay? On the 9th, you'll have big, relatively bright Mars. It's not a real bright Mars right now, but you have a relatively bright Mars right next to Regulus there. Take your binoculars out, get a good look at them. You can see it without your binoculars, but really take some time to enjoy that on the 9th. But you'll note just how much Mars has moved as the week has gone on. And Venus has moved with it, just not as far. And so Venus will not, by the 9th, Venus will be on this line that connects Eta to Omicron. Down this direction. And so you'll see Venus will have moved over here by that time, and the separation with Mars will have grown, but they're both still in prograde motion moving this direction. Let's take a moment and blow up this region where Venus sits above Omicron. So now we've blown this up over here. Omicron is here. If you get your binoculars out, you'll see that Venus sits right above 2 stars. I would start watching this a few days beforehand. Once again, it'll really give you a sense of the motion as Venus catches these 2 stars, 18 and 19 Leonis. They're about 6 magnitude stars. Maybe you could see them, especially 18, if you got really good dark skies. But I think I would need binoculars to do it. But they should be relatively easy targets in binoculars. And on the evening of the 9th here again, as Mars makes a great pairing with Regulus, Venus is going to make a nice pairing in binoculars with 18 and 19. It's not really a pairing, it's a pairing with a pair. Sorry, I wanted to sing some sort of song about pairing with a pair or something like that. And so Venus is right there. We're going to blow this region up again. So get that, enjoy that view. But also, when you set, this is 18 and 19. So we've blown this up to have 18 and 19 up here now. And sitting below 18, come down here to 19 and drop about that distance as part of a triangle of stars right there is R Leonis. And so let's see if you can find R Leonis. Make a sketch. Get out, make a sketch. Start a long-term. We've done a lot of long-term observing projects in these videos. I hope you're still doing them all. But you can start a long-term observing project because R Leonis is a Mira-type variable. An asymptotic giant branch star, a star that gets most of its energy from fusing hydrogen into helium in a thin shell or helium into carbon in a thin shell alternately. And so it's you got these shells burning, and this is an age star. This is a star that's gone through the red giant branch, what we would call the helium burning branch, the helium branch stars, and then ascending the asymptotic giant branch again. I say ascending, it's getting bigger, but we're talking about on an HR diagram, and we've drawn those for you here before. So this is a great example of a long period variable star. Has a period, see if I can remember, just over 310 days. So it has a period of just over 312 days, I think, if I recall. I looked it up at the AAVSO website. I suggest going out to the American Association of Variable Star Observers, see what you can find out about this star, R Leo, and look up R Leo there. If you want to, become a member. Why not? You get more data and can do more stuff, and you can make some observations and turn them in there and do other things. But the R Leo, it gets brighter and dimmer with time. So over time, and you look at how bright the star is, it's going to do this and get brighter and dimmer and brighter and dimmer. And the thing is, for this star, and Mira-type stars in general, the difference between brightest and dimmest can often be a factor of 100. It's 100 times fainter here than it is here. Now, we've just crossed over one of these peaks and are starting to get dimmer. And so R Leonis right now is a little bit fainter than 19 and 18, but it rivals 18 and 19. And you can watch it. It's brighter than these other two stars that's here next to it that are 9.0 and 9.6 magnitude, right at the limit of what your binoculars can do. You might need a small telescope to see those other stars. So you might not see these two stars in the triangle right now at all if you don't have a telescope. You just use binoculars, you go 18, 19, boom. Now you're about to lose this region of the sky. It's sinking into, as we orbit, Leo is getting lost behind the sun here, and it'll pop back out. I don't know. I should have looked this up for you. It'll pop back out the end of August into September. So you'll be able to start observing this again in a month or two, month and a half or 2 months, and you can start to pick up this region. So you'll sit there. You'll sit there excitedly waiting to see R Leonis again because you enjoy it. Watch it for the next week or two or however long you can observe it, 3 or 4 weeks. And see if you can see that it's getting fainter because it's on this descending part of its brightness curve. And see if you notice it getting fainter. And then wait patiently a couple of months. I think you'll be pleasantly surprised at how hard it is to see when it comes back. It's going to be really faint. And if you have a telescope, it's going to look more like these two stars than like 19 and 18 when it comes back. That's how much the light will have changed in a couple of months while you've been off doing other things and letting it do its thing out there. So this is a wonderful example of a Mira star. I think it was the 4th one ever discovered of this type. Mira was the first. That's why we call them Mira stars, Omicron and Eta. And so that's why we call them Mira stars. But this is a beautiful example. And if you just start now, make yourself a note, put it on your calendar to come back in a few months and observe this region and sketch it again and see what's going on. And I think you'll appreciate it. So watch Mars and Venus. Watch Mars and Venus separation starting to grow, but see how they move into Leo now and how they dance with Eta and Omicron and Regulus, these stars in Leo. And then if you're up for it, see if you can find 18 and 19 Leonis, and then see if you can use 18 and 19 Leonis to find R Leonis. And if you find R Leonis, start paying attention to how bright it looks relative to some of these other stars in the region. And I think it'll be fun to think about. This is a star that's nearing the end of its existence as a star, as it pulses in and out. Once stars leave the asymptotic giant branch, they go on to either become supernovae if they're massive enough, or planetary nebulae is what most stars become. But that's a story for another time. We'll pick this back up. We'll try to remember and refer to this in a few weeks. As always, folks, thanks for watching, and I hope you have clear skies in the week ahead, and we'll have something new for you next week.